Okay, I'm gonna cut that other video short. This will be my fourth video, showing one example of how I choose to set my forces and pull out my equations. So I'm gonna do number 13. I've got mg down. I have my applied force that is 30 degrees from the horizontal. I have friction, so I'm going to draw my frictional force is opposite my direction of motion, and I'm on a surface, so I have my force normal. This is what my free body diagram looks like for problem number 3. I'm going to draw my two sums of forces equations, right, because I am in the horizontal and I'm also in the vertical. So I'm going to do the horizontal first. So my frictional force minus the cosine component of my applied force. And let's decide, are we accelerating or are we moving with a constant velocity, or are we at rest? Let's see. Moving with a constant velocity. All right, so that means I'm in equilibrium, so that means I can set the sum of my forces equal to 0. When I rearrange my equation, I can say that my frictional force is equal to my applied force cosine of my angle. The sum of my forces in the vertical direction, I'm going to have 3. I'm going to have my two upward forces, so the sine component of FA plus my force normal, and they're acting opposite my friction or my gravitational force. So I'm going to subtract mg, and they are also equal to 0, right? Because this thing is not accelerating in the vertical direction. So when I rearrange my equation, I would say that FA sine theta plus force normal, my upward forces are going to be equal to my downward forces, right? And this equation is saying that my leftward forces are equal to my rightward forces. And when doing this, we can solve for the mass of my object. So let's take a look. We have our 60 newtons for our applied force. My mu is identified as 0.3, and my theta is going to be 30 degrees. So in this case, because it's giving me my mu, you can also assume that we're going to use our frictional forces equal to our coefficient force normal. And in this case, I'm going to substitute that in. So I'm going to take this and I'm going to substitute it in here. Because I ran out of space, I'm going to write that equation down here. So my mu force normal is going to be equal to FA cosine theta. And I'm going to do some substitutions. I want my force normal by itself, so I'm going to divide both sides by mu. And then I'm going to take this, which is equal to my force normal, and I'm going to plug it into here. So my equation then becomes FA sine theta plus FA cosine theta divided by mu is equal to mg. Because our equation is kind of long, right, we could divide by g on both sides, but I think I'm going to save that to the end just because we already have a fraction, and I personally don't like that. So we've got 60 sine 30 plus 60 cosine 30 divided by 0.3 is equal to m times 10. So I don't have my calculator, but you're gonna do these, put these functions into your calculator and solve. So those are less than 1, maybe 30. I can't venture a guess. Less than 100. I will guess less than 100. So once you do these functions, right, we're going to divide by 10 to get m by itself, and then you'll get your answer. I'm sorry I don't have a calculator to actually get the answer for you, but this is how you would do it.